Hi everyone. So today we are going to discuss very interesting examples based on Bayes theorem. So let me take the example 5 of exercise 13.2 from chapter probability. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result for 0.5% of the healthy person tested. That is, if a healthy person is tested, then with probability 0.005, the test will imply he has the disease. If 0.1 percentage of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? So before solving this example, first of all, let us understand what do you mean by positive, negative, true, false, and so on. Because these are the terminologies used especially in the medical field. So before I jump into solving this example, let's understand these terminologies first. Now, if you just see any person, either he has a disease or he doesn't have a disease. You can see that disease is present, is true, or disease is not present is false. Similarly, the laboratory test results could be positive or could be negative. Now let's understand this matrix. Suppose if a person is suffering from a disease and the laboratory test result is saying that yes, he is indeed suffering from the disease. So we call it as true positive. So that scenario is absolutely fine with us. Person is suffering from the disease and the lab result is also showing that person is suffering from the disease. Similarly, if the person is not suffering from any disease and the laboratory result is saying that he is not suffering from any disease, so this case we call it as false negative. False means there is no disease. Negative means result is showing that there is no disease. So these two scenarios are okay for us. Person is suffering from disease, test result is saying yes. Person is not suffering from the disease, test result is also saying that person is not suffering from the disease. Now there are other two scenarios when the person is suffering from the disease, but the test result is saying that he is not suffering from the disease. Or sometimes if the person is not suffering from the disease, but the test result is saying that person is suffering from the disease. No, for example, if a person is suffering from the disease and the test result is saying that he is not suffering from the disease, which is kind of an error, that scenario we call it as true negative. True means person is suffering from the disease. And why negative? Because my result is saying that despite he is suffering from the disease, my test result is saying that he is not suffering from the disease. Similarly, if a person is not suffering from any disease, but the test result is saying that he is suffering from a disease, that scenario we call it as false positive. False means he is not suffering from the disease, but the test result is saying that he is suffering from the disease. Now remember, not all the laboratory tests are 100% accurate at all the times. So many times, occasionally, it happens that some of the cases could fall under false positive or true negative kind of scenario. But of course, these cases are very, very rare, I can say that. But yes, we can't rule out these kind of cases also happen. Now, again, going back to this example, now if you have understood this concept, then we can easily solve this example. Okay, so let me go back to this example again. It is saying that laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. That means this is a case of true positive. Disease is present and blood test is detecting in 99% times that yes, this disease is present. So this is a true positive. So this is the probability 0.99. You can see here disease is present and laboratory is able to detect this with probability 0.9. That means for the remaining 0.01, laboratory is saying that disease is not present, but in fact, disease is there. So disease is there, but laboratory result is saying that it is not there. The probability is 0.01. 1 minus 0.99 is 0.0. So this is the first thing which is given. Now the second part. However, the test also yields a false positive result. Just now I have explained to you what do you mean by a false positive. False positive means person is not suffering from any disease. That means a person is a healthy person, but still laboratory result is saying that person is suffering from the disease. This case we call it as false positive. The probability is 0.005. So you can see here there is no disease, but still laboratory result is saying that he is suffering from a disease. This probability is 0.005. So obviously, if there is no disease and laboratory result is negative, what would be the probability? 1 minus 0.005, it would be 0.995. This is number two. Now, the third information which is given to us is if a 0.1 percentage of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? We can't just say that if the test result is positive, that means person is 100% having the disease, because there are these kind of cases where test result is positive, but in fact the person is not having any disease. So what they are saying, what is the probability that a person has a disease given that his test result is positive? Now, test result could come positive on those cases where person is suffering from disease, or it could still be positive for those cases where person is still not suffering from the disease. So these are the two scenarios. Now, so before solving this, the information given is 0.1 percentage of the population actually has the disease. So if you just see here my population, so 0.1%, that means 0.001 probability of having a disease. So remaining population having not any disease, that probability is 0.999, right? So what I want to solve the problem, given that the test result is positive, what is the probability that a person is indeed having a disease? That means I want to go to a upper path. Person is having a disease and the test result is positive. But just now I have explained to you, test result could be positive, either for the person suffering from a disease, or even for the person not suffering from the disease. So these are the two scenarios. So this is the upper scenario, and this is the scenario given in the lower part. Now you can see, but we are interested in the upper part. So obviously the numerator would be the probability of having a disease and the person is positive, that is 0.001 into 0.99. So that will be my numerator. What would be my denominator? Person is having a disease and positive, or person is not having a disease and his result is still positive. So what is this probability? Is 0.001 into 0.99 plus 0.999 into 0.005. You can see here. So which is 22 by 130. 22 by 130. I hope you have understood this example, and it's the very easy way to solve such kind of examples. Thank you so much for listening to this patiently. Thank you.